All right, ITS128, it's January 29th, and we are still in Chapter 3, I believe. So today we're going to finish up Chapter 3 and talk about setting breakpoints and so on, and then we'll go through a little breakpoints exercise, and then I'll show you I'll go over the next assignment. So let me share my screen here. Am I sharing my screen? Main screen. Oh, okay. All right. So can't minimize the screen. Put it over here then. All right. Let me bring up my. And can you at home see my screen? I hope you can. All right. So 128. This is the 29th. So we're still in Chapter 3. And so I'm going to pull up the slides for Chapter 3. And I think we ended about. I think we talked about the background images for forms. The form has a property named background image, so you can set it to an image. Let me open up. Let's see. If you go to back to Laulima and look at resources and sample programs. Chapter 3 sample programs. I'm going to download this onto my desktop. And right click, extract all. And in Chapter 3, let me open up this average race times, because we're going to use this for to go through the breakpoint example. So I'm going to start up this average race times, and you can do this too. And let me just start this up. You can see what this looks like. I've got to log in, I think, sign in. I guess I don't have to sign in. All right, so this is a program. We're going to get to this later, but in the meantime, I think if we, here we go. Yeah, I extended the assignments because I noticed the settings were all messed up. I think I had it set so you can only submit it once. You couldn't resubmit. And there were some other things that were messed up, so I just set them all correctly, and then just extended it, just so in case you guys want to do that. So let me look at the assignment. Yeah, I extended them because I had a bunch of stuff. I think I had it so you could not resubmit, and is messed up. it was just messed up. So this, if we look at the form, this is the form. You should be able to, there should be a, we got to get faster computers in these classrooms. So see, there's a background image here, and you can set the background image at equal to some picture if you want to upload a picture. So that's what we're talking about here. Set, so you know, you can upload a picture. There's also a group boxes and panels control where you can group controls together. A group box can, with a group box, you can actually, you know, put a name. This is it right down, personal data. This is a group box. So you can put a name right up there. With a panel, there's no name. And with a panel, you can specify the border style. With the group box, you can't. The other thing about group boxes and panels are, if you're gonna have radio buttons, you know, for radio buttons, you have a set of radio buttons, and only one of them is supposed to be set at once. And if you click another radio button, the previous radio button, it goes off. So you have like 5 radio buttons. It's only one can be set at once. The reason they're called radio buttons is in the old days, cars used to have radios, and there were these push buttons to switch to a different station. It was mechanical. You'd push a button, and the dial would actually move, and when you pushed another one, the previous one would pop out again. So those will be useful later on when we get more into forms. Now, one of the things that is not covered in the second edition of the textbook that some of you are using, and that is breakpoints. So what I've done is I've included, if you go to the resources folder and you go to just the resources folder, the root here, I've included the section, a tutorial out of the 4th edition of the textbook. So this tutorial talks about breakpoints and how to single step through your program. And we use this average race times program that I just loaded up. So the idea of a breakpoint is you can actually stop your code at a particular point. You know, you turn on your code, it's executing away, and you set a breakpoint, which means it stops. When it gets to that statement, just before it executes that statement, it stops. And at that time, you can go in and you can examine variables. You can examine the values of the different variables. And then you can hit the F11 key and you can just step through one statement at a time. And so that's what we're going to see today. And so the lead into that is we talk about errors, using the debugger to locate logic errors. A logic error is an error in your program that's not caused by your mistyping a statement, or you leave a semicolon out, or you spell something wrong. Those are syntax errors, and the compiler or Visual Studio can find syntax errors right away, and it sticks the red squiggly line underneath it. Logic errors, the debugger or Visual Studio has no idea, because it doesn't know, what exactly you're trying to do. So as long as all your statements look right, as long as everything's spelled right, got the semicolons in the right place and all that, then Visual Studio says, okay, you know, you're ready to go. But you could be doing something like adding up something wrong, or you could be adding instead of subtracting, or something like that. So if you're testing your program and it runs fine, but you're getting the wrong answers, the breakpoints and the debugger and breakpoints is a good way to isolate errors. And we never really had breakpoints in the old days. You spend a lot of time desk checking your code. But so logic errors are mistakes that do not prevent the application from running, but it causes the application to produce incorrect results. So we can have mathematical errors. We can be assigning a value to the wrong variable, assigning a value to the wrong variable, or assigning the wrong value to a variable, and so on. And so finding and fixing logical errors usually requires some detective work, so to speak. And so Visual Studio provides some nice debugging tools for that. And one feature is breakpoints. So a breakpoint is a line that you select in your source code, and when the application is running and it reaches that breakpoint, the application pauses. And when it's paused, you can go in and examine variable contents and values stored in certain control properties, like the values that are stored in a text box and so on at the time. And so in this example, we're going to go through this. Here we're setting. Here we have. I'll just go through this first. In this program, we can set a breakpoint where as soon as it gets to this statement, it stops. And some of the things you can do is, while it's stopped, you can roll your mouse over the different areas, and it'll actually pop up and say what those are. Like, you roll your mouse over this runner1 textbox.text, and it actually shows you what is in there. And so in this example, presumably the user typed in 25, and it shows 25, and it's a string because it's got quotes around it. And so there's some windows down at the bottom that we'll see. There's an autos window, which displays a list of the variables appearing in the current statement, as well as 3 statements before it and 3 statements after. That's kind of nice. And the current value and the data type of each variable are also displayed. We have a locals window, which displays the list of all variables in the current procedure. Procedure is an old term for method. Should probably put the word method there. The current value, it displays the current value and the data type of each variable are also displayed. And then we also have a watch window. With the watch window, you can add names to this watch window. When it starts up, it's empty. You can add names of variables in there, just specifically the variables that you want to watch. I mean, you could have a method or a program that's got a zillion variables, but you're only interested in 2 of them. And so these other 2 windows might be kind of hard because, they're filled up with different variables and you only want to look at 2 of them. So you can just type those 2 variables in a watch window and then set a breakpoint. And at that point, you can see the values of, you can more easily see the values of just those variables. So we had autos, locals, and watch. And so this is an example of locals. And so we've got these variables here and the values for those variables, and these are the types. Okay, we'll see all this. And so we're with Visual Studio, you're able to single step. So you set a breakpoint, it stops at that breakpoint, And then you can hit the F11 key step by step, one by one, and it steps through the code. You can stop, see the variables. You can see the executions take place. You can see variables as they take on values, and it helps you isolate if something is wrong. So you can identify the line or lines of code that are causing the error. And there's this when it's running, or when a breakpoint is hit. I guess you wouldn't say when it's broke. When it's paused, the menu bar up above has got these. It looks like this, and of course the stop debugging is there. When it's stopped, there's a continue button. If you want to start it back up again, you're done looking at it, you start it back up again, you can click this. This is the step, one step at a time. Step over means skip, and so like if it's a for loop or something, and you want to skip over the whole for loop because you want to go past it. You don't want to step all the way through the for loop of 10 times or whatever. You click step over, and it just skips over. All right, so so if we look at this one, in this program, I'll tell you what. Let's bring up the exercise because this goes with the exercise. So in this little exercise, and those of you that bought a new book, this is in there. In this tutorial, we open up this average race times application and we test it for logical errors. So the idea is that the user enters in the finishing times for 3 runners, and then it computes the average for it. So we'll start out by typing in 25 for each of these runners. And so if it's 25, 25, 25, the average race time should be 25, right? And so we'll see that there's an error. It doesn't say 25, it's something else. So then we want to, then we want to set a breakpoint where the first runner value is taken on, reads this thing, and then it adds it, reads this thing, adds it, reads the third one, it adds it, and then it computes it. And we can step through that code to try to isolate where exactly the problem is. I can't remember what key this is. There's a key here, but you can always do Visual Studio C# breakpoints. Breakpoints. And so here's another description of it from the Microsoft website. You can, setting breakpoint, you can click F9. That's F9. So that's the key there. Okay, so let's go back to this. So here we're going to set the breakpoint at runner 1, and we're going to step through it. And we're going to look at these different windows to see what's in there, see that, and we'll be able to find the error. This is F11 right here to step through one at a time. I think this might be F6. Not sure. Can't see it. Look, I think that's F6. All right, so let's go back to this thing. All right, so I'm gonna run this, and I'm gonna type in 25 and 25 and 25. And click calculate, and we end up with 58.3. That's not right. So let me exit this, and let me view the code. View. And we see that we declare these three variables, runner 1, runner 2, runner 3, and then average. And then we parse whatever was entered into the runner 1 text box, parse it into a double value, and set that equal to, or set runner 1 equal to that value. And we do the same thing for runner 2 and the same thing for runner 3. And then we calculate the average using this formula. You can probably already see what's wrong with that formula. And then we write the value out into this label, the average, this average value, we write that out with 1 decimal point. And then this clears it. So let's set a breakpoint. Let's set the breakpoint to runner 1. So you move all the way over to this gray bar right here, this vertical gray bar, and you click right here next to the 28. Boom, there's a breakpoint. And so now when we start this up, let's start it up. Am I recording? Yes, I guess I'm recording. That's what that red dot means, right? All right. Yes, I'm recording. Okay, sorry. All right, so let's run this. And I'm going to type 25, 25, and 25, and then calculate average, and it stops right here. So let's look at this. If we roll the mouse over the runner 1 text box, we see runner 1 text box is equal to 25. Right there, see it's 25. If we go over to here, we see that runner 1 is equal to 0. Why? Because the assignment statement has not been executed yet. That double parse has not been executed yet. So it is set to its default value, which I guess is 0, right here. And if we look down here at the bottom, this autos table, we see that the average is still set to 0, runner 1 is still set to 0, the runner 1 text box is equal to 25, text equal to 25, and we can look at the locals, and we see all these local, there's objects and so on. The sender is this, it's a text box. This is the coordinates of where we pressed, exactly where on the button we pressed, and then these are these values here. And this is the watch. Here we can type in a value if you want to. Okay, so let's step through this. If you notice up here, this is continue. We can continue, or we can press this one, step into. That's the one we want to do. So I'm going to click on that. Okay, so the first one was executed. Now when I roll my mouse over the runner 1, it equals 25. And if we look down here, we see runner 1 is equal to 25. Look in locals, runner 1 is equal to 25, but just changed to 25. And we look at watch 1. Oh, what happened to it? Did I do something wrong? I'm going to try this again. Runner 1. Here it is, 25. All right, and let's do it again. Step again. Boom. And now we see that runner 3 this has not been executed yet, but the runner 2 has been executed. This still says 25. This says 25. And if we go to autos, we see that runner 2 is now equal to 25. Go to locals, we see this red because this just happened. The 25 is set to that. And so let's do it again. Click. And now we're down here at average. And we see that runner 3 is equal to 25, runner 2 is equal to 25, runner 1 is equal to 25, and runner 3 divided by 3, see what the problem here is that runner 3, you know, you're supposed to put parentheses around. We want to do the adds before we do the division. And right now, because of operator precedence, it does the division first. You see this runner 3 divided by 3 is equal to 8.33333, and then that's added to runner 2 and added to runner 1. So that's the problem. See, there's 25, 25, 25. If we execute this one more time, click, we see now average is equal to 5.8333. So it took 25 plus 25 plus 8.33333, and it ends up, you end up with that. That's what was computed. We see this is what was computed down here. Here's the average. That's what was computed. And if we go through one more time, exits. This is compute. This is written out. Now we see that average timetable label.txt is equal to 58.3. That's this. This string was returned 58.3 because it's 1 decimal point. The label here is set to 58.3. And then we click one more time, and looks like we're done. Okay, so let's fix it. So I can get rid of the breakpoint by just clicking on it again. It's gone. Let's continue here. Okay, so that we're continuing. We've popped up the. Where's the screen? I guess we're done. All right, let's start us back. All right, so if we fix this, we can just put some parentheses around here. And now when we run this, 25, 25, 25, and we get the right answer. Let me see, this is a label. All right. Okay, I think that's all I was going to. Let me see, is that it for this tutorial? We went over this, that, step over, exit. So there's various ways to add breakpoints and get rid of breakpoints. I like clicking. Okay. So the thing about breakpoints though is that you have to be smart enough. You have to know enough about your program to know exactly what should happen after this is executed. So, you know, you have to be smart enough to test it with values where you absolutely know what the answer should be. So, you know how your program is supposed to calculate them. And then when you test with those values, so that's why 25, 25, 25 is nice to test with, because the average of 3 of the same value is just equal to the value. And so you execute it and you see that the answer is wrong. And then in this example, it's very simple because there's only one statement here. But you know, it's possible that you might have read the wrong one. Like let's say you got something like, let's say you mistakenly made it like that, for example. I mean, we're still going to get an error. We get, let's put 25, 50, 75. Okay, the answer should be 50. That should be the average. You calculate the average, and it's not 50. Well, what's going on? You know, so what do? You can set a breakpoint, and let's run it again, and put in 25, 50, 75. Calculate average, and it stops there. And we see, okay, this is 25. Yeah, that's right. Okay, let's execute it again. Boom. And we got this one here, and it's 25. Oh, runner one. Oh, okay. Oh, that's my error. You know, and it's this. You execute this again, and you end up with, you know, runner one is equal. Runner two is equal to 25. Well, that's wrong. Runner two should be equal to 50. So I don't reference runner one text box at all, or runner two text box. All right, so so that's how I use breakpoints. Okay, so let's look at the next assignment. Assignments. It's the Paintjob Estimator. Okay, this is out of the textbook. Painting company has determined that for every 115 square feet of wall space, 1 gallon of paint and 8 hours of labor will be required. And the company charges $20 an hour for labor. Create an application that allows the user to enter in the square feet, that'd be this number, and the price of the paint. And so, so if it's 110 square feet and you're spending, you know, I don't know how much paint costs. Does anybody know about how much a can of paint costs? Like 20 bucks or something? I don't know. Huh? So anyway, so you've got a text box to enter this. What? 15 to 30. Okay. And so for, you know, 115 equals 1 gallon and 8 hours. So half of 115 is a half a gallon and 4 hours. So you can figure it out. You multiply the hours by 20 for the labor rate. And so you want to output the number of gallons of paint, the number of hours required. So the number of gallons of paint would be so you go 1 gallon divided by 115. That's how many gallons over 15. That would be the number of gallons per foot. So it'd be a very small number, some fraction, you know, 0.1 gallons per foot, or yes, actually less than 0.1 gallons per foot. So you know, that's how you calculate it out. And you want to display the number of gallons, the number of labor, number of hours of labor, the cost of the paint, and then what the total labor charge is, and the total cost of the paint job. And so you're going to make an application from scratch. that does this. So you're going to start out with something like I'm going to create a new project here, and it's a Windows Forms application, and I'm going to name it. What should I name it? Paint quote. How about paint quote? I'm going to put this on the desktop. Call it paint quote. Why not? And so got a toolbox here. And so on top of the form, let's make it say paint Richard's awesome paint quoter or something. I don't know. Whatever. And on that, I want to put, you're going to enter the square foot and the price of the paint. So we will have a label. I'm going to make this label bigger. And the label is going to say enter square feet. And then we're going to put a text box there to enter it in. And I'm going to make this one big also. $18. And I'm going to name this text box, not what they say, but I'm going to name it TXT square feet. And then that's the square feet. And then I got to enter the price per gallon. So let me put another label here. I'm going to do this, copy both these things, copy, paste. And this is going to be price, not name, price, paint price per gallon, colon. And I'm going to name this text box TXT paint price per gallon. And then I'm going to output number of gallons of paint, number of hours. Okay, 1, 2, 3, 4, 5. Let me just do this. I'm going to do this. And this is going to be number of gallons required. Number of gallons. And I'm going to make, this is going to be an output. So, you know, there's a number of ways you can do this. So this can be a label, or it can actually be a text box that's read-only. So I kind of like the text box to read-only. That way I can make it exactly like the other ones. So I'm going to do TXT total gallons or something. Gallons. And I'm going to make this read-only just so it doesn't look different. Read only. Oh, yeah, let's do this. Read only, true. And labor hours, I'm gonna make it so I can read this thing. Number of gallons, hours, cost of paint, labor charges, total. I gotta line this up better somehow. And this is gonna say hours required. I'm gonna change this to gallons required. I'm gonna say gallons required. I'm gonna make this be hours required. I'm gonna say this paint cost. And this might be labor cost. And this can be total cost. And this will be, the name of this one will be TXT total. And this will be TXT labor cost. And this can be TXT paint cost. And this can be TXT hours required or something like that. Is that it? They all got nice names now. All right. And I probably want to have a submit button. And what's a calculate button? Maybe a calculate button. Have it say calculate, and I'm going to make it a little bigger. And the name of the button will be ETN calculate. And what else do we want to have? It doesn't say anything about buttons, so I'll make exit, I guess. Should have an exit button, I guess. Exit. ETN exit. And it should say exit. All right, so and so we can do double click on calculate. And here's where we start typing in the code. So we could have square feet. I'm going to say double square feet. Huh? Oh, this text size, yes. So double square feet equals, I'll start out with 0. And have we learned tripars? We've learned tripars, right? Wow. And what other variables we have? Double. Paint price. And then we're going to have double gallons required. I'm just initializing all these things to 0 for double hours labor. And double paint cost. Double labor cost. And double total cost. Actually, they should be just. I'll just leave it. And then we're going to do, well, we can just do this. Double parse txt square feet. Text. And this can be double parse txt paint cost. I'm gonna name it. Did I name this paint cost? No, paint price per gallon. Txt paint txt paint. There it is. Paint price per gallon dot txt. I'm gonna put double labor per hour equals 20. So let's break it down to per square feet. So actually, I think I'm gonna stop here. And first of all, it'll leave me something to do Thursday. We'll finish this up Thursday. But in the meantime, maybe you can think about this. Well, I tell you what. Let's do one calculation. So let's fill in one of these things. Let's fill in that. Yeah. So gallons required is going to equal square feet times we got to figure out gallons per square foot. So so let's figure out gallons per square foot first. Double gallons per foot equals 1 divided by 115. Oh, yeah, 115. Right? If it's if 115 square feet take 1 gallon, 1 square foot equals, I mean, 1 gallon. One square foot would be 1 gallon divided by 115. I should put double. Actually, these should be constants. Gallons. Double. Double square feet per gallon equals 115. This should be constant. This should be constant. Because those aren't going to change, are they? And so this can be 1 over square feet per gallon. Okay, so that's the gallons per foot. So we've got gallons per foot. And then we want to figure out how many gallons it takes for whatever the square feet is. So we take the square feet, which is this one, you multiply it by gallons per square feet. Gallons per square foot. So this is like, if you want to do, let me comment this. So this is like square feet times gallons per square feet equals gallons, right? Because these two, this and this cancels with this, and you only end up with gallons. Okay, so gallons per foot. So that's the gallons required. And we can just write that out now. TXT gallons required. Oh, total gallons. Dot text equals gallons required. Dot toString parentheses N1. What is it? Oh, paint price per gallon. Let's do it, and then let's do paint cost too. So we've got gallons required, so paint cost is going to equal gallons required times paint price. And then we can write this out. TXT paint price, paint cost. paint.text equals paint cost, toString, parentheses, C. Oops, I forgot to put this in quotes. So I'm going to run this. And let's try and start with numbers that I know. 115 square feet and 20 bucks per gallon. Calculate. Requires exactly 1 gallon, cost exactly $20. Well, that's nice. Let's say I only have 100 square feet. It's like my office, I think, is maybe about that. And calculate. Ooh, I only need 0.9 gallons, and the paint cost is going to be 17.39. Should probably, can you buy, when you go to a paint store and buy a bunch of paint, you have to buy it by the gallon, right? You can't buy like you can buy it by quarts, I guess. Okay, but I bet it's not, if it's 20 bucks per gallon, I bet it's not $5 per quart. It's probably more. Okay. Okay, well, let's start with this. So you can work on, think about the rest of the numbers till Thursday, and then I will then on Thursday I'll hint you through the rest of them, and then maybe for the rest of the assignment I'll do something like, well, you can only buy a gallon at a time, so you know you can paint out of the last gallon, put the top on it, stick it in your in the corner of your garage for the next 20 years until you sell your house and throw it out then. That's it. When we bought our house, the folks before us, had this stacked up of paint gallons. It took us about 10 years before we decided to throw it out. Anyway, okay, so good. This is a good start. And so what I would do now is I would exit this. It doesn't work. Let me just throw in the exit. Double click this, close. There, now the exit works. And so exit works. And so to hand this in, I would let's say I'm done. I would save all. I would exit.
I thought it would be like close solution.
Huh?
I thought it would be like close solution.
Oh yeah, I guess that would work. Should work. And then this is my application. Right click and send to compressed. And so now here's my compressed file. Go back to my Laulima, and here's my exercise down at the bottom. I would go choose file and go to my desktop, and I would take the desktop and take the zipped one, open, and it's right there, and then I would submit, and I successfully submitted my work, and thank goodness I am able to submit this an unlimited number of times up to the due date. After the due date, if you have not submitted anything, like let's say you go away for 2 months, it's still the semester, 2 months, you come back and you go, oh gosh, I forgot to hand in assignment 3. Oh, it's past February 14th. It's okay. You get one more chance to submit it. Okay. So, and the advantage of doing this, I've made all these unlimited because now when you come back, you can just start with this. You can upload it now, come back on Thursday, and then you can download it back down again, and you can continue, and then you can resubmit it. All right, so are there any questions? Okay, it's 4:22. Good time to stop. Yes. Uh,
I don't want you to grade it.
oh, no. So I would never grade it until after the due date.
Okay.
And after the due date, if it's there, then you can't do it again. If it's not there, I'll wait until it's there. Yeah. All right. Any more questions? Okay. Thanks for watching.